All right. Well, hello, everybody, and welcome to another episode of React Wednesdays. My name is TJ Van Tol, and I am one of the hosts of the show. I work as a developer advocate at Progress. With me, as always, Dan Wilson.
Hey, folks, I'm Dan Wilson. I work at Digital Primates. We do enterprise React consulting. We also curate the enterprise React newsletter. So if that's your kind of thing, Google it. We never sell your email or spam.
And our special guest for today, our returning champion, I think. You might be our first repeat guest that I can think of. Michael Labriola, welcome back to React Wednesdays.
Thanks, but now you've set the bar. I want returning champion to be like what we go with each time.
We do need, I should get a special graphic, right? We can put on you. For,
That's fantastic.
Or a big wrestling belt.
Ribbon. Yeah.
Something you could get satellite dish on would be good.
Yeah. See, now you're giving me too many ideas. I should get Progress's design team on this. There's some potential here, right? Send out custom stickers or shirts or something.
I did get the awesome swag pack from Progress, so thanks for that. But yeah, I think that I could work with a belt. I can get up to my lanyard and my playing card decks and.
Nice.
Yeah, we have some good swag people at Progress, A+. So given the right motivation, there's a way.
I did find the fuzzy dice pretty fantastic, by the way. Just on a side note, those were for the casino. I thought that was a good touch, but the fuzzy dice were kind of fun. They're still hanging in the back of my office. So
very cool. So today we want to talk about, and I'll see if I get the big text up here. Wow, that's really big. I guess it's appropriate.
Yeah.
Breaking up big apps. So maybe you could start by maybe just introing to this, what you mean by this sort of topic and what it is we're going to talk about.
Yeah, that seems fair. All right, so here's the gist, right? We and it's when you use words like big, everybody has a different opinion in their mind. So let's kind of talk through that as well. What I basically mean by this is that as your React app or anything else grows, eventually the period of time it takes to download it and to get it running on a machine can get longer and longer and longer. So that makes sense, right? In small apps, we don't really much care about it, and this isn't such a big topic the smaller your app is. But as your app grows in size, you got to figure out how you avoid, perhaps avoid might be a better term, making your user pay the penalty for your code as you keep downloading it over and over again. So in this case, what we really mean ultimately is how do we get it faster? But the way we do that is we talk about breaking it into pieces so that we might have some alternate delivery mechanisms. Seem fair?
Very cool. Yep. So how do we want to drive this? Do you want to share your screen? Because I know you have some stuff that you are going to drive through this. So you want to chat a little bit more about what that means first?
Yeah, you know what? Let's talk about 2 seconds about what it means, and then we'll dive into some code, and we'll do it that way. Fair enough. Okay. And we're actually going to spend a little bit of time too today in something called the Webpack Bundle Analyzer, which is basically a tool for Webpack to let us to do that. So TJ, you're seeming to nod in acknowledgement.
Yeah, well, I'm familiar with I'm glad you're going to demo this for me because it's one of those things that I feel like I should be using, but also overwhelms me because there's lots of boxes and determining which box is which is always a little bit of a struggle. But I sort of get why you're saying this because I've been in this boat before too, right? You have a quote unquote big app, which like you said, it can mean any number of things. And it can be tricky to know, okay, well, crap, what approach do I take? How can I isolate out bits of this? And then how can I make sure this isn't in my bundle because it's not immediately obvious? Back in the day, you'd have separate JavaScript files for all of this. And you go into Chrome and say oh, well, did my page2.js load in Chrome? It didn't. Looks like my job is done here, right? Whereas now, you have bundle.js and some random string of numbers JS, and God knows what's in these files, right? So without something like that, you're sort of flying blind.
End of the day, right? It's just a tool that is just going to introspect both, some of the metadata and other things in order to figure it out. But yeah, what its job in life is just to kind of tell you, well, so actually take a step back, right? In case folks aren't aware, there's lots of tools you can use for it right now. We'll be playing with Webpack, but Webpack's a bundler, right? Takes all these independent JavaScript files, as you mentioned, and tries to stick them together into one place. And it's kind of funny because half of what we're talking about is also how to say, well, yeah, it's great that you're willing to do that for me and put them in one place, but maybe don't. So it's figuring out which ones we don't want to and how we want to move them around as well.
Yeah, it's also
Yeah,
a
and
great
that-
way to break your app. Yeah.
Yeah. Oh
is.
yeah, it's fantastic.
And that sort of slides into maybe another question we're talking about is, if some developers out there testing their own app locally, they don't have this problem. Everything loads instantly. It's probably already in the cache of the browser. Maybe you could kind of walk through maybe someone would diagnose needing things like this.
Yeah, no worries. We can definitely talk through that a little bit. And if we, just in case we don't get enough time to get to it, a couple of things I'm just going to mention and we'll kind of name drop them on top. If you're using Chrome, there's a lot of great tools in Chrome that allow you to simulate bandwidth, simulate like slower network conditions, things like that. So look into those, because that is a great point, Dan, which is that ultimately at the end of the day, it's really nice when it's served from my machine and everything looks fantastic, but it's not my end user's experience. And even worse, if we're developing an app that's supposed to be consumed by desktop and mobile. One of the big things we have to remember is that when we are out there and we're serving something on a desktop, that's one, locally is one thing, desktop's another. But then when we put it on somebody's mobile device, they're, many times paying for that antenna time, whether it be through battery or through data bits, they're paying to download that thing. So you probably don't want to overwhelm them with 60 meg of stuff they don't need. To load up your app, because it might be a slight disincentive to, I don't know, depending on who's watching, do business with you, visit your app. I don't know. I know Dan's models a lot on his Instagram feed, so it could be a disadvantage if he was linking to that. But yeah, I mean, what we're trying to do is be somewhat regardful of the people that we're sending data to, and figure out what we need to send them, how often. And it does change for environment, but if you don't pay attention to the fact that it's different than your experience sitting on your machine, you're going to have a lot fewer friends.
Yeah, for sure. And there's definitely well-established metrics put out by reputable companies like Nielsen that say for every second of time you add to the loading of some app or page, you'll lose this amount of people. And the losses can rack up pretty fast. It used to be the web user had about an 8-second attention span, but I think with all the ADD in the water these days, it's gone down precipitously from that.
Yeah. So I comment on that, right? I agree with it. I think some of that's a little hard to interpret sometimes because, right, it depends on how motivated your user is. If you're throwing out a generic application or a generic web page, which they might click through because they saw it as a link, I agree with you. You have almost no time to capture them.
Right.
Probably a little different if they've decided to come there because they want to work with you. And sometimes those metrics are averaged and they don't always give you a good view, but I think the point's the same. I don't know that we should necessarily on our app worry that it has to be a second, or a quarter second or whatever it is, but we certainly really don't want to make it like 100 meg over 30 seconds, because we can all agree up front, nobody's going to hang around and really do that if they can help it.
Yeah,
Unless
if they
you
have a
like
choice,
the
they'll
one,
eject.
right? Yeah. If you have the one key answer to all the entire
Right.
universe in your app, maybe someone will hang out, but other than that, nobody's staying around.
Or some enterprise app where there's just no substitution. I mean, they'll stick pins in your voodoo doll, but they have to be there.
I mean, the more captive your audience, the worse you can abuse them, is
That's
I think what you're trying to say.
Pretty much.
It's all about the one-liners we can produce for you here, DJ.
Yeah, I'll have to remember that one. But you're right, though. We say it as a joke, but there's some truth to it. Like if you're building an internal app for your company, and lots of times those are very large apps, you can get away with a little bit more, right? Like it doesn't mean you don't want to make your internal apps fast, because you want your people that you work with to be happy and productive and such. But you have more leeway than if it's like your public shopping cart, right? Something that you care a whole ton.
Yep. And I mean, honestly, that's the gist, right? And also, there's other things that go into it, right? So realistically, if you're on a local intranet for an enterprise, you probably also have just a different amount of delivery pipeline to be able to get them the app, things like that.
Yeah.
Although the whole working from home thing could be changing that for a lot of people. But yeah. You can do a whole lot more if you've got a giant network pipeline to send bits down, and a whole lot less if you're sending it over a wire somewhere or wireless. Anyway, point's the same though, is that, I mean, sometimes there's necessity. In fact, oftentimes there's necessity for these really big apps. And back in ye old days, as I like to refer to them, we had several 100 megabyte apps that we had to deliver internet-wise in 2004. And if you think about how network scales, like that still sounds big today, and back then it was huge. So breaking up things is really, really important to do it right back then as well. The techniques are different, but the concept's the same. Just basically, you have to scale things, and you have to recognize what your user's going to go through to use your app, and then weigh all those things, positive and negative. Because also, and I reiterate this a lot when I'm talking to clients about these sorts of things, all of this takes effort. Like breaking up your app takes effort, right? And not just effort now, it takes effort to maintain, it takes some debugging. There, as you mentioned already with Webpack Bundle Analyzer, it takes understanding the tool set, crawling through things, figuring out what you want where. And that stuff's all good and important if you have the use case for it. But that's also got to be weighed in, because realistically, if you're going to go through, like, I don't know, 3 months of work and testing to save somebody a 10K download, you might want to do something else with your time. But if you're talking about breaking up a several 100 MB app, it's a much bigger win.
Well, I'm dying to check some of this out.
All right, well, let's talk about these two things first, and then we'll check it out, to quote Dan. So the gist of this is as follows, and we'll talk about both sides of it. I was in my in the preamble to this conversation, I was in terms talking to TJ about the new hotness versus the old way of doing things, but there's a little bit of ways of going about it. When we talk about breaking up an app, what we really are talking about is two things. What sorts of things need to be there, which are sort of, you can think about it as the dependencies of the app. Got to have them. Actually, they got to be there before the app can really run. And then we can talk about the things that maybe we don't have to have for the app to run. And as your app grows and the complexity of your app grows, the difference between those two becomes clearer. But just as a way of explaining it right now, imagine that you have a really big app that somebody's going to walk through and navigate through. It's entirely possible that they're never going to hit all the surface area of that app, right? They might hit a couple screens, they might go through. People who are more web designer-ish approach might think about it as things below the fold, but one way or the other, the gist is that a certain percentage of your users, if the app is large enough, will never use it all. Those sorts of things, the things that people may or may not ever use, are great candidates for lazy loading, things that we might pull in later. The things that we need before we start up are still great candidates to separate and to do different things with, but we're using a different mechanism then. What we're relying on at that point and what we're going for is figuring out how to send less things over the wire, which means we're trying to figure out how to use the cache better inside the browser. So what we're really going through when we talk about breaking up a big app is, first of all, how do we use the cache better? Because all of you have, a browser that has a cache and it does a really good job, honestly. So how do we use it better? And then second, what things do we not need to send, right? I mean, that's our two avenues. That's the two things we're trying to go for. Make sense?
It's hard to get much more local than the browser.
It in our world, it definitely is hard to get more local than the browser. And I do see a lot of people reinvent browser caching, which is a little crazy, and try and do a lot of stuff. Browser cache is really good.
Yeah. Have enough programmers, enough coffee, and they'll reinvent everything.
Well, and it's definitely old school too. Like the browser caching is been around for basically quite literally from the start. Like I think it's like part of some of the original HTTP specs and such. So
yeah, and it's had a lot of testing on it, which is another good reason not to create your own, right? Like as I'm fond of saying, so the old joke in computer science is that there's only two jokes in computer science, but I don't know. So the point is that caching's hard. Caching validation is even harder. Browser does a pretty good job of it, but we could use it really well in these cases to do things, because modern JavaScript apps, as you pointed out, aren't 3 JavaScript files that you download anymore, right?
Yeah.
You've got these directories upon directories of recursively nested node modules that reference each other, and at some point or another, we need to serve a bunch of that stuff to our user. The question is, how much of it do we want them to download, and how much of it do they have to download every time? That's what we're trying to manage.
Yep.
All right, so I'll stop talking for a minute. Well, I won't stop talking for a minute. That's a lie. I'm sorry, I lied to you. But I am going to go ahead and share, and we'll talk a little bit through this example or so, and just some pieces that we're going to go through. Sound good?
Sounds good.
All right, let's do it. Let's try to do it again. All right, so TJ, per our last conversation, I tried to already go ahead and zoom in, but tell me if that's not enough.
You could go 1 notch bigger for sure.
You got it. I can go 2 if you'd like.
I think that's all right.
Cool. The R on React right now is seriously an inch tall for me. It's kind of fantastic. All right, so
I got to get you guys off the like TV sized monitor thing. I think that's your biggest problem.
You'll pry it from my cold dead fingers.
All right, cool. So just because this is how everything in the universe works, this is a to-do app because that's how it goes. And props, by the way, to you'll see in the commit history, Kyle Blake at my org, who actually wrote some of the stuff for me to make it usable. What we're going to do, though, is that basically this one app is just going to be here, just a small to-do app, and I'll run it in a moment. But we're going to look at it a couple different ways. All right, so first thing we're going to do is we're going to look at it as a single bundle, and then we'll break it up in a bunch of different ways. But to do that, we're going to talk a little bit about the Webpack config to start with. So Webpack configs can be a little bit of voodoo. There's also some science behind them. But let me just read out what's going on here as a starting point, which is basically no optimization. We're pretty much not going to see an optimization key in here, meaning we won't see a top level thing, and that is what we're going to mess with the rest of them. For the most part, we're just compiling some React, we're doing some loading, and you're going to see something in the background when we run this Webpack bundle analyzer, because we're also running a dev server, but I'll point that out. So the big gist here is that when we compile this, though, we're actually going to generate a stats file with Webpack bundle analyzer. And you can do this from the command line too with a special flag called dash dash, I think it's dash dash stats. Or, but the gist of it is that it's going to generate a JSON file, and that JSON file is just going to contain all the information about what got stuck into a bundle. So when I run this in the background, and it's going to run a little slower with my screen sharing, but we'll work on it. When I run this in the background, what we're going to get is we're going to get a two things right now. We'll get a little bit of a working app that works with one bundle, and then I want to go through, and the most important part is that we want to go through the Webpack bundle analyzer first and be able to see it. So hopefully you can see that right now.
Yep.
And this is the most basic version of the Webpack bundle analyzer. And for right now, it is for this app. And in fact, considering you can tell that I'm opening the bundle analyzer and not the app, you can tell what I think is more important in our particular world here at the moment. All right, so the world needed another version of a to-do app. So here we have one. You can click things, you can check things. The gist is, though, ignore the sock.js for right now. I'll explain a little bit more, but basically that's just so that it can talk to the Webpack dev server. But what we can look at is this. We have one giant bundle called main.js. Everything is stuck in this one giant bundle. And as TJ was noting, there's lots of boxes, but what you can do is you dive down into these, you see that each of these little boxes is really just kind of an explanation of what code is there and what it got and where it pulled different things in from. The Webpack bundle analyzer is really cool in that way, and that it's giving us a whole bunch of different information that we can use, but it can be a little much, right, in terms of trying to get everything. Right now, though, this would correlate perfectly. Just to clarify, if we went over here and actually looked at our network tab, when we refresh this page, we'll see that it's downloading one thing, right, which is main.js. And that's why our bundle analyzer has main.js. So right now, we're one app, everything's stuck together in one, and let's see, relative size over here. Oh, sorry. Where are we at? I don't know. We're huge, right? Like we're a big app right now. We're a bunch of code that we're downloading for no particularly wonderful reason. It's just all stuck together into one big thing. But here's the thing. There we go. 1.17 meg. All right. So here's the thing, though. For a small app, this isn't a really big deal, but you can see that because we're using React, and React's going to have dependencies on things, and things are going to kind of bundle all the way down. Even for this really tiny little app with a handful of lines of code, we're downloading like a 1.1 meg bundle. Odds are, if I got rid of React development and got rid of a couple of these things, this would probably be maybe like real 500K or so of development code. But nonetheless, it still illustrates the point, right? Which is that we have this little, I guess I'll start at the beginning. We render an app, okay? And our app in this case is really nothing more than a little bit of a class name and a couple of classes and a little bit of React code. This part's not the important part right now, not for what we're doing. But the gist of it is that we're making a pretty little app, and we're doing it in like 1.17 mega code with no with just one bundle. So that's kind of our default way. Side note on that. Let's talk about that for a minute. For those of you who might have come from a different language, and this isn't an exact analogy, but Webpack's kind of like a linker that you'd see in a compiled language, which means that its job at its best is to kind of figure out and reach out to the rest of the world and figure out all of these different dependencies you have, which ones you really need. And you've probably heard a tree shaking, but that really means that it goes through and it tries to figure out what it doesn't need and leave those out. It does much more of that in production mode, but its job in life is to just deliver what it's supposed to. And then by default, it wraps that all up into just a bundle and delivers that bundle. And that's kind of happy. As TJ mentioned earlier, they have a bunch of random characters on them. And part of that reason is because of the fact that we really do enjoy how well the cache works in the browser, but sometimes it works so well that it doesn't know that we are delivering a new file. So the hash at the end and the random characters are just a way for us to make sure that we can distinguish versions.
Actually, question real quick. Does it matter whether, when you're looking at the bundle analyzer, is it going to matter whether you're in development mode or production mode? Like, is that going to change up what you're analyzing at all?
Completely. So that's fun, huh? So yeah, if you're really doing this for realsies, if you will, you definitely want to be looking at production mode code, it's a lot slower. But production mode, it's really going to shake all these dependencies out. Production mode, it's really going to do all the work to figure out what does and doesn't need to be there. Dev mode is a really quick proximate way, but you have to get really good at ignoring what you should not be looking at by yourself. So you have to have your own imposed filter.
Yeah, I have to imagine, since like those development files stand out big, but they're going to be gone, like it's not going to flag your actual potential issues and such.
Yeah, this would be a bad way to determine size, but it's an okay way to determine what goes into each bundle, which is more our point here, right?
Okay,
so for this point, it's about bundling, cool. But yeah, if you were trying to use this to determine final size, you need to be in prod mode. And by the way, just for fun, the list of other things you need to be in prod mode for, do not actually try to do profiling in development mode. Do not try to do memory profiling in development mode, because all of those things work completely and totally differently. I watch people customers spend a week trying to find a memory leak in React, and it was because they were profiling dev mode code, and it's keeping lots of things around because it's trying to be helpful to you that it doesn't really do in production. So that side note, prod's important for those things. Fair?
Yep.
All right, cool. So we'll leave this around for a minute, and we'll actually get into a little bit of Webpack config if we wanted this thing to work a little differently. Okay, so over here, I'm going to go into this, and it's going to be the same app, same stuff, and there's no real change in here. But what is different a little bit is what I mentioned is that we'll see this optimization node here. Now, optimization is kind of an interesting thing because it's the node under which there's about 1 million configuration properties, and they're all named and special in their own way and do different things. But here, I'll read this one for you. We're doing some really basic things. We're basically saying we want to optimize this bundle and we want to split it into chunks. In this case, we're really just going to split it into one chunk, which is that we're going to take everything that happens to show up in node modules and we're going to stick it in a vendor bundle. Okay, and this is what you see in what you mentioned before. And this is kind of the most common way of going about doing it. We're also going to do some other stuff to basically overrule Webpack. Webpack's pretty smart. It tries to do things and say like, well, I know you told me to put it in a vendor, but if it's really small, maybe it doesn't make sense, et cetera, et cetera. We're just kind of overriding some of that right now. But the gist of this is that this is going to build a vendor bundle, and it's going to throw everything that was in your node modules in your vendor. And you get that by creating this node and creating this split chunk. So now we're going to see two things, right? We're going to take our code and keep it in one place, and we're going to throw node modules in another. And this is nothing new. This has been around a long time. But this is totally underestimated as far as the value goes. Because if you think about it, once you've kind of got your project established and we actually have things kind of working, we probably don't change our node modules nearly as often as we change the rest of the code in the app. So let's say we're, working with this really great, component set from like Progress or somebody. That was my little, just how that worked.
Nice plug.
Yeah.
Didn't you like that one?
Smooth.
It's totally smooth, and especially since I called it out, it's what makes it so smooth.
Yes.
So, but I don't need to change that, or I don't need to re-download that to my users every single time I change a bit of my code. So, although this is old in the sense of it's been around a while, keeping stuff partitioned so that I keep a vendor bundle means that I'm really creating a bundle that is going to exist and probably persist. So you can think about this as a time-based thing, right? Meaning that this is the sort of thing, and it should launch in a moment here, I'm building in the background, but this is the sort of thing I do if I say, well, how do I want to think about delivering this app? And when I put that optimization in here, you'll see versus the first one now, come here, that I've got this vendor bundle, which by the way is 1.16 of the 1.17 meg in the vendor bundle. But okay, let's think about what actually happens now. A user hits my site and they download the vendor bundle and they download main.js. Now I say download both because remember, we're talking right now about the types of things that they absolutely have to download, which means if we were to look here and go through, and let me do that. If they were to look here and go through, we're going to see that when we get here, the first thing it's going to do is download that vendors bundle and then main, because these are really dependencies that have to be downloaded, okay? But after it downloads this vendor bundle, and yeah, it might have been big, but after it pulled this down, it's going to cache it, which means that if I continue to iterate on my app, this is going to be cached already. This tiny little bit of code, the 48K comparatively, is something that is going to change maybe more frequently, But if my vendor bundle doesn't, how much faster is it for somebody to go out and hit my app and only have to download 48K than this whole thing? So this is overlooked. And by the way, all the strategies we're going to talk about today are not mutually exclusive. You can use them together. But our first thing is really, how do we use the cache already to make sure that people don't re-download what they already have? And in this case here, what I've just done is basically said, grab everything from node modules, stick it together, throw it in one big bundle, and cache it for me. And we can see that over here if we go in, because now if you'll notice, this big thing that is up on top is vendors, and this tiny little thing over here is main, which means this is my app. That is what I actually have, my app.js, my to-do.js, and my main with some CSS. But what is actually happening as far as the download size is it's almost all inside of this bundle. And in subsequent reloads, this would be cached, and if this changed, it would download. So I make such a big deal out of this because people tend to jump to the other strategies and the other techniques, but this is the heavy lift. Like making sure that people aren't downloading the same node modules a million times every time they hit your site is the heavy lift. That's what's actually going to do a lot of the portion of making sure things load quickly up front. Does that make sense?
Yeah, I do have a few questions though.
Yeah.
So first, is this, I believe this is built into Create React app, right? Or at least they do something similar, because I feel like this has magically happened for me without me knowing it.
Yep. Yeah, it's so common that pretty much every basic default sets up something like this as a starting point because of the fact that it is so, it's important and fairly ubiquitous at this point.
And then, so as a follow-up, so the actual like cache headers, I noticed that there's no like hash in the name of the vendor file in this case. Would you put a hash in there so that like you could set like really aggressive cache headers on your server? Is that typically how you do it for production? Okay.
Yeah.
And what generates that hash? Is that something that's just not there because this is development, or is there a little bit of extra Webpack config that tosses that thing in the file name?
Tiny little bit of extra Webpack config, which we can maybe go through towards the end, which basically is just telling it how to build the name and where to use the hash. So Webpack, as it's building these, actually has already assigned a hash to each one of these. That's how it keeps track of it internally. And you basically just give it a template string to say, this is where to stick the hash in my file name.
And nowadays too, is because like I don't work too often anymore, but things like CDNs or web servers in general, is it pretty common for like, if you just pick one of these platforms, for them to set some of those aggressive caching headers for you? Or do you have to be like smart enough to say, I want my JavaScript files to have crap, it's been too long. Like what's the like the expires to be like forever, right? Sort of thing.
All right. So it's going to depend obviously and be vendor and CDN specific, but the most common stuff these days is done with e-tags and is set up, and basically you can control the scenario under which you cache it. So there's really a couple different ways. First of all, there's basic time expiry and name sort of things, which is that I should go back and get something because it expired. But what happens more often than not with like more modern web servers is that the browser will actually make a request back to the server and say, all right, I'm being asked for this file. What the browser will end up doing, especially with e-tags, is it'll include the hash of the file it has in its cache, and it'll say like, this is the file I currently know about. And it can actually be compared on the server to see if it's the same file before it returns. So if we don't use something like the name hash, and it's really not like a huge overhead process, it's still very light, but then what we can do is be aggressive and actually use things like real hash protocols between the browser and the server, which are supported through e-tags. But if we do include something like the name of the file and just automatically hash it, we kind of get around some of that because of the fact that right from the beginning, we can limit the number of even requests that we would have to make for the file to, or back and forth to figure out what's going on.
Yeah, I find like if anything else, it tends to make debugging a little bit easier because like sometimes that it's been a while since I've had to dig into this in detail, but that like little like ping of the server, sometimes like browser debugging tools haven't historically been the greatest of spelling out exactly what happened there in detail sometimes. So
yeah, and for the most part, if you look at nowadays, like at least in Chrome and stuff, it'll tell you that it was something was served from cache right in the network tab, which is kind of cool. But yeah, it's always going to be harder if there's more requests versus the fact that you just know or you can see what's happening. But like both strategies are valid, and there are people who don't use the hashes in the file name and rely solely on the server. And I'll tell you where that's most useful is where you have a mix of static content and dynamic. Like let's say that we had maybe we don't have or this web app isn't standalone. Like maybe there's a giant website and then this app is part of it. So we need to link into it or reference it. It's really hard to update static HTML files every time the name of a hash or event, something would be generated differently out of Webpack.
Yeah.
So in those cases, people will use a static name and they'll rely on things more like e-tags to figure out where it's at. But internal to your app, it's super easy to use hashes in here. And honestly, it's just going to make your life easier and things generally faster. So use it, right?
Yeah, that makes sense. And you don't want to get into like server config that's different, like based off directory or something like that. That gets into chaos very quickly.
Yeah, again, everything that you do, right, has some cost, and whether it's the cost to the end user of your app or whether it's the cost of the development hours, and it's not the development hours, it's the debugging hours that go into everything. So there's always cost. So it's just a game, right? It's like, where do I spend my time and my money? And so the goal here being, of course, hopefully I spend it in such a time that is most useful to me and not, fruitlessly. So.
Yep.
All right, so in this case, we've done this and it's cool, and we've made this big vendors bundle. But as you can see, we've bundled up a whole bunch of URLs or a whole bunch of node modules in one. I just want to kind of do this and because it's kind of fun, to be honest, to show how far this can go, and how much configuration capability you have. I'm stealing this piece of code and I'm going to give it credit because I think it was cool when I found it. So it's from Dave Gillerson on his blog. He actually goes through and writes it. And I've done stuff like this before, but I thought his solution was really elegant. So I might as well give him props and show it here. He actually wrote one that said, all right, well, I'll tell you what I'm going to do. I would like you to split those chunks, but how I want you to figure out the name of the chunk, and Webpack lets you provide functions for a lot of these things. So if you notice before where we'll go back here, we just named the chunks that we wanted directly. So we said this one was called vendor. In his case, he basically says, what I'm going to do is I'm going to find the name of the node module, and then I want you to replace like these ats to make them, there could be a little better way to do it, but that's okay. To make them a little bit more safe, you could use thunking and some other things for this. But pretty much what he did was he said, I'm going to make a node module for every package. And so I'm going to show you what this looks like in terms of fun, because I think it's kind of cool and explains a little bit about where you can go. But in this case, it's really saying, I don't care what the minimum size is, and I don't care how many requests you make up front. You can make as many as you want to, infinite number of them. But I'm going to take every single node module, I'm going to break it in with an individual package name. And if you do that, you'll see suddenly that we have a whole lot more modules, but each one of these modules now is independent, right? So every one of those pieces that we loaded is being loaded up independently. Now that's kind of cool in a way, because if you think about it, and I'm not saying that I would necessarily go do this in production, but let's just talk about why it's cool. If you think about it, what we just did is basically said, well, even if our under the hood, even if we change a node module, a single one or one or two, now you're actually only downloading the one or two that actually change, as opposed to the whole bundle, which encompasses them. Because the more code we group together, any piece of that code that changes necessarily changes the whole bundle, and the user has to re-download it. So here we went back and basically said, let's make the atoms really, really tiny, almost back to what you said about having individual JavaScript files, right? And make the atoms really, really small. And yeah, there's a little overhead. If you notice, this is creeping up just a little bit as we go along, because anytime we're going to break it up, we have a little bit more overhead, but it's still actually not half bad. And now we're actually loading these things up individually. And if we were to go over here, you'd see that in the browser, every one of these things is just kind of being loaded up front.
It used to be back in the day that we were very concerned about how many HTTP requests were required, because certain browsers would only do a certain amount and then queue everything else. Since then, the limits are much larger. But is there any kind of limits or caution you would advise folks against just going and implementing this crazily? Like, is it 10 requests? Is it 200 requests?
Now, so nowadays it doesn't quite work that, as long as you're working on modern infrastructure, and I have to put that big asterisk on it because,
IE6 for the win, baby.
Yeah, I once wrote a web server for my Palm Pilot, and I wouldn't recommend that being a production level thing. But but in general, with modern HTTP, it's not actually a separate request for everything. It opens a channel and then it negotiates and keeps sending things over the same open channel. So it works a little differently than it used to in the old days. So it's not quite the same level of complexity. So here, I would actually say that you might have a bigger problem with, again, going back to TJ's point, debugging and things like that, of seeing what's going on here. From a practical standpoint, is it really going to cause a bunch of problems? No, because it's not like you're making separate requests and enduring that massive overhead for it as long as you're on a modern server. But the flip side of why would I not do this in production? I don't know. It feels like I'm going a little too far, right? Like I could technically just deliver all the atoms to the universe to you, and you could reassemble your packages yourself too. That'd be really efficient. But maybe somewhere in between is where I would go. I don't know. Personal bias.
Yeah, it kind of depends on the app, because I think if you're in a, like, I mean, this is a to-do app, right? In a real world app, you would have node modules would be insanity, right? So there's like, I think in people's like actual like enterprise production apps, if you tried to do this, you would have like a monstrosity going on in your network tab,
awesome,
right? And yeah, and I also think like those little, like you said, there's a little bit of overhead, right? Because there's a few node modules here, but if you're, once you start to get into the hundreds, probably thousands in some cases of node modules, those like little bits, you're gonna be able to optimize more away when you're tossing all of those in a single file and such.
Yeah, and there's a little bit of overhead in the way JSONP works and some other things, but basically, for the most part, what it's really doing is wrapping the mode module in a closure. So it's pretty much saying like, okay, well, I'm going to make a closure that is attached to the window and sort of allows me to have this module registered. But there is overhead, and again, this is less of a go do this and more of a, it's really interesting that if you're smart about it, and for instance, you know that maybe the part of the app that you're working on totally fictitiously is more analytics based. So you know that it's likely you might be updating charting stuff, but you're not really working over here. You could smartly partition these modules in such a way that the things that you are most likely to change are the ones that are separated, because then what you're really doing is you're reducing the overhead for your user to download each piece. So the point of this is more just the idea that you can, and if you're smart about it and don't just accept the automatic create, React app sort of config, you can be really smart about what gets delivered to your users and be really, really, really smart, because you know more than that computer is ever going to, about what things are likely to change. And although side note, amusingly, they have all sorts of loaders that even like look at Google Analytics data in order to figure out what areas of your app should be broken up. So there's all kinds of cool stuff. But beyond that, you can, for the most part, decide like what I really need to deliver and how I should break it up. So I won't say much more about that other than to say, this is intelligent, this is smart, and this is your first line of defense, because use that cache. Like all the dynamic loading we're going to talk about is great, but at the end of the day, there's probably a whole bunch of stuff they have to load every time, and that all of your dynamic loading is going to share. So don't optimize the outer loop before you optimize the inner loop. All right, that was old school for me right there, but that's okay. Let's go ahead and talk about breaking things up lazily right now. And I'm going to dive into a little bit of stuff now, which is things that, you can find all of this on blogs, but I'm hoping to add a little color to it. So if that's okay, if you'll indulge me, I'd like to talk a little bit about some of this stuff.
Yep.
All right, so same app, we're loading an app, but we did a couple of things here that are a little different. And they come down to two things that are the buzzwords for like the modern era, which come down to lazy loading and so basically a combination of lazy, React.Lazy and of Suspense. So let's talk a little bit about what both of those are in terms of these different components. And both of them are on this screen, so I guess we'll use this one as a starting point. These are the two pieces I'm talking about. And while certainly there's implementation details that are complex, they're actually kind of simple on the starting point. So we're going to take them apart in terms of what actually happens. So for the most part, we've been using imports in module syntax throughout this app, and we can see it. So import React from React. But here you'll see that we're actually using the import function. And so just to kind of clarify what this is for everybody out there who's maybe not come across it, import is kind of a function that takes something which is like a module, okay? And its job in life is to return a promise. So it's going to take a module, and this promise is going to get resolved when that module has been loaded. So if we extrapolate that just a little bit, React.Lazy is the type of thing that takes a function, and we'll talk about that with a factory in a moment, that's expecting to eventually get a promise. And so how these things really work together is they're just using the infrastructure that we already have in the browser to pretty much say, you know what I'm going to do is that instead of knowing I have this stuff up front, I am going to go ahead and say, let me hold on and show something, and this is just the English language version of it. Let me show something different on the screen. Doesn't matter what it is. It could be a thing that says now loading. But Once I actually have this thing that I want to load remotely, so I want to load from a server somewhere, then go ahead and start showing it. So it's about the idea of waiting, showing the user something else, eventually showing them something that we're going to lazy load. And the way that we do that is all based on the stuff that everyone else has used, which is promises. So this import statement is kind of cool because it's going to force us to go do a load. So let me kill this example and start that one in the background so we can look at it together. But what it's going to do is it's going to force a remote load. And we'll look at this working first, but I then want to take apart this thing because there's actually a lot happening here. That's kind of cool if you get it and like kind of have a chance to take it apart. And by the way, one of my favorite things to say on this is that if you understand the rules on how this stuff, so you can totally understand when you're allowed to break them, right?
Yay.
And that's the greatest part about learning all this stuff. All right, so here we go. This is the newest Webpack bundle, and you'll see what actually has happened here is that it has made my all bundle, and then I have a vendors one, and I have my main one, and then each one of those things, the dialog, to do, button, and input, are all their own little chunks. And we'll talk about how that happened, but that's just these pieces. But this only shows you the bundles. Where you really get it now and where it makes a lot of sense is if I go here and look at what gets loaded. So up front, I may have gotten the vendors again in the main, and I got the bundle for the button because there's a button on the screen. But when I click that, that's when it goes off and actually loaded the dialog and the input. And it didn't happen until I clicked that button. And had I stayed on that forever, I would have never loaded those, right? And that's the whole idea, is that I'm trying to intentionally now defer things. This would be a terrible example of the way to do this, because why would we possibly want to lazy load those things when somebody clicked this button, right? It's like the worst possible idea. Well, I got an idea. We'll save you a little bit of load time when you're probably not paying attention, and then make it go much slower at the time you actually want to do something. All right, terrible idea. So we don't
sign
really
me up
want...
for that.
Yeah, exactly, right? So this isn't how we want to do it, but the idea is still the same, is that we're trying to pay attention to what we need when. Again, being intelligent to have a good sense of what people are likely to use. If your to-do app, for instance, lazy loads the part that shows to-dos and adds to-dos, again, probably a little silly, right? Might want to have that thing able to do some sort of interaction before you lazy load parts. But if there was, let's say, a complicated set of adding to-dos or admins, maybe that's the part you load. All right. Either way, I click this, loads the dialog, loads the input. The reason that actually happens today is this, which is that dialog is set as a React.Lazy, and that React.Lazy is an import. I'll talk more about this maybe if we get a chance, but web chunk name, really, this is what's called a magic comment, which is that Webpack can actually understand and read comments in your code. And so you know how we set vendor as a special name of a chunk or a bundle before? This is actually just telling it, hey, this one that you're going to keep separate, name it dialog. And that's the reason that this is called dialog. And that's the reason that if we go over here, we saw dialog here. So we can do these through configuration, but sometimes it's kind of handy to do them in line when you're doing code, and then you're not messing as much with configuration. So anyway, just so you know what that is.
Actually, that you sort of answered my question, but you don't have anything in the Webpack config here that specifically calls out like dialogue. Then it's just all magically done through the comments.
All magically done through the comments because of this. You could totally do it in the config too with just pattern matching and stuff. But in this case, it's here. Now, one of the fun things is that it really doesn't care, which means if I were to go over to my button and I were to say like, okay, that's called dialogue, and I were to go back here, you would actually see that dialog loaded up front to load my button now, and nothing new loaded. There wasn't a second dialog because they both got stuck in the same chunk now.
Yeah, makes sense. Yeah, a couple other questions real quick. Sorry if I'm interrupting here. So suspense here is that mostly buying you, like, because I like the syntax around here is super elegant. Is that mostly buying you the I don't do this until it's ready sort of deal here? Like, because I'm imagining you could do this without suspense, but you'd probably have to do some magic to say like the callback for this is ready sort of deal.
Yeah, and you can really think about suspense as really just doing some internally. It's throwing a promise, but what it's really actually doing is pretty much saying, "Hey, I understand that there's going to be a promise, and that promise is going to be resolved. So just watch for the promise to be resolved." So you could write it yourself. It would be the same sort of thing, which is give me something that's going to be a promise that's either already resolved or will be resolved, and I'll just keep displaying something as a fallback until that time.
Okay.
One question I had was, in an application where there are multiple user roles and capabilities, would one or more of these techniques be appropriate to hide the capabilities that a user just wouldn't have access to?
Yeah, that's probably actually one of the best use cases, right? So good way to phrase it, which is that when you can partition an app into role-based things or security roles or however it works, or even just maybe average use case. Like, we work on some really big apps and the odds that a user sees all of it is basically 0 on any one day. So that's a great time to lazy load stuff, right? Maybe I lazy load just the administration portion of the app when I get to somebody actually wants to go configure something, but before then I don't bother to do so. So anything that you can partition, and roles is a good one because it's a natural partition, but any way that you can partition it and think about it in terms of time. That's what's interesting here. If you think about the first technique I showed, it was almost like space, right? Like we partitioned this stuff over here and then we let this live in a cache. This is more about time. What do I need to start versus what do I need later? And if you think about it that way, only things that you should be doing lazy on are things that actually very clearly can be used. We can use the word later to somehow describe when we need them, right? And if we can't describe these things as saying like I need this later, we probably shouldn't be using lazy loading to do it. Maybe there's a couple of reasons for it, and we can get to those. But for the most part, we're still going to end up, or we have to load these, and there's going to be a more overhead, or at least a little bit more when we do. So we really want there to be an advantage, and that advantage usually comes with the ability to use the words either later or I might never need to get there. Fair?
Yeah, Christian brought up A/B testing as an example too. So I think that's a pretty good scenario also, because you're only going to need one or the other.
Yeah, for sure. And I think there's a lot of really cool things. And sometimes lazy can be used even in the sense that we know and we want to lazy load things slowly in the background, like dribble it down to you, because eventually you'll need the whole app, but you don't need it to start with. So there are, again, other little scenarios on where you'd want to do so. But primary use case is the idea that I either don't need it or I don't need it now. And those are the two things you want to remember.
5-part wizard to register for something, you could render parts 1 and 2 and then do 3, 4, and 5 a little later, and the user would never really know that it's coming down.
Yeah, exactly. And you don't necessarily just have to do it when they click on it, right? Like you could start loading 3, 4, and 5 while they're filling out 1 and 2, and that's still cool because it's still later. There's still this delta of time, and that's what is most important here.
So I have one last question, then I'll let you keep going. How careful do you have to be with shared dependencies in this sort of situation? Like if your dialog needed utils.js and you're lazy loading 6 things that all need utils.js, how smart is Webpack out of the box at like doing that, or is it gonna like duplicate it in each bundle that needs it? Or I imagine this is some way configurable, but like what's sort of like, is there like a sane way of approaching this?
Sure. It's pretty smart if you use the kind of the configuration we talked about before, where most of the vendor dependencies are in one place. It's harder when you start getting interdependencies. Like let's say the dialog needed to pull in the button, which needed to do this. At that point, to be honest, using the dynamic import syntax, in other words, this one and not these static ones, is your friend, because it'll just basically treat them all as modules. Where you actually can get into trouble is if you're dynamically importing some of them, statically importing the others, and then sometimes you switch back and forth. Meaning on some places I statically import something that I intend to dynamically import in other places. That's where it gets a little messy. So if everything that you're statically importing either comes from a vendor bundle or you promise yourself you're not planning on dynamically importing later, you'll probably be okay.
So sort of choose one or the other for these paths that you recognize.
Yeah, I think that's reasonable because again, Webpack's going to do its best to figure this out, and it will. But where I've seen problems are when I have something that loads that then in turn statically imports something, but that thing that I statically imported here was dynamically imported here, because at some point it gives up, and I don't blame it because I would too. But for the most part, it's pretty good. Like the bundle in this case, it does actually a pretty darn good job. Fair.
Okay. Yep.
All right, let's take this apart for a minute because I think it's kind of fun. As I mentioned, this is the type of thing that imports or just brings in a promise, right? And it's specifically a promise in this case that would be intended to return a module. So you can think about this as import is the type of thing, again, which is going to take some sort of name, and it's going to return a promise, right? And that promise that it's actually going to return is actually going to be like an ES module. That's what we're really returning. So let's have fun with that for just a second so we can kind of see, because I think this is a cool way to break it down. So if we think about that, we could actually we'll leave this here so I don't have to retype it later. We could actually take this thing and say, well, since we know what this thing is, this is actually just going to return a promise, right? So I can return, spacing got all weird. I don't know how. Sorry, 1 second. But that'll drive me crazy, and I just can't deal with it. All right, so this is going to be the type of thing that returns a promise, right? So I could just say something like new promise.resolve. All right, and a promise.resolve can take the sort of thing that I want to resolve automatically in terms of it, or what I'm going to do. So in this case, I'm going to pretend that it's a module, and modules are the type of thing that are an object that have a default export. So right now, I'm just going to kind of throw this in here. And we know that most React functions are basically something that looks like this, right? A props thing that returns maybe some syntax. So we'll do something like, it's my new code. There we go. All right. So I did this because of the fact that I want to see kind of how this works over here, and I think it's kind of cool to understand it. That or if I make a typo, we'll see where that's at. That's all right. Uncaught. Cool. I'll look at that in a moment. But what we'll do here, actually, we're just going to do this. This is the magic of television. So we're just going to go ahead and grab that. Cool. There we go. So magic of television. But what we're trying to do, and the reason that I want to talk about it or see it that way, is that if we go through and understand it in terms of what we're doing, we recognize that the lazy thing is actually not all that interesting, or at least it's not, it's very cool, right? But what it's really doing is it's just a promise that's going to resolve itself to some sort of module. And in our case, the module is something that has a default export, which is just a React function. It could have been a React element. It could have been anything that we wanted it to be that it can render. So I think that's actually kind of cool to realize and to see what's happening. And again, suspense is basically saying, all right, the thing that you put inside of here is the type of thing for me that is going to ultimately be a resolved promise, but it's okay if it's not, and this isn't exactly right, but it's good enough for now. It's okay if it's not resolved yet, right? That if it's not resolved, then I'm going to go ahead and display a fallback, which in this case is just our null renderer, but could be anything. So I'll display this until such a time that this promise actually resolves. And that could resolve because we did an import. That could resolve because we did a server call that went off and got some data and figured out what it needed from the data, and then created an array of 50 React elements and then put them all on the screen. All of those things are completely reasonable because of the fact that it's really just the idea of something that's going to resolve a promise. So knowing how you can piece that apart makes a huge amount of difference in what you can actually do with this code later. Make sense?
Yep.
Cool. All right. So in here then, and you look at it, it's the same sort of thing. If I bounce over to the lazy button here just to kind of illustrate the point in time, this is already asynchronous, but the reason that our button takes a moment to pop in on the screen right now when we do it is because of the fact that we're actually very much intentionally saying, hey, this is a button, and then go ahead and wait 2 seconds before we resolve the promise. But the neat thing here is that you could think about this again as the sort of thing combined with lots of different tools and caching and things of this nature that could go out and get a bunch of data, could figure out not just a generic, let me render something on the screen, but let me go off and render this loading button until such a time that I get some data from the server. And once I figure out what that data is, build up a really complicated set of components, and then in one shot, produce them and send them back to the UI in a lazy fashion and get this really nice, smooth user interface. So while suspense and lazy are often used together just to facilitate lazy loading, the power here is a lot greater than that, right? They're really generic utilities that allow you to render an alternate view until a time that any promise is resolved, and something that says, I am going to eventually execute a function. And actually, you know what? Sorry, if you don't mind, I didn't talk about that. So give me just 1 second here. We are probably familiar with things like use memo and stuff in React right now, right? Which are hooks, and I don't know why I'm not getting code completion, but that's okay. That are hooks that will, well, actually I do know why I'm not getting code completion. So they're hooks that are out there, and we might have something that looks a little bit like this. And we're used to seeing these, and what they are in the case of things like use memo is we list our dependencies, and then in here we have a function that runs. And in this function, we return some value, right? Ideally based on foo and bar, and that gives us some new data. Okay, this is the interesting part, and you'll notice it's really similar to lazy. In JavaScript, this is our primary way to facilitate lazy loading, which is that what we're really saying is that we're giving React.Lazy a function which is a factory. it's not going to do anything. It's not going to execute this function right away. It's just going to hold on to this function. This function, when executed, is going to eventually return a promise. So what that means and how this ends up working is that when this is displayed on the screen, it's going to try to render lazy button. And the first time it tries to render lazy button is the first time this is actually going to be invoked, which is the first time this is going to go off and do the import. So what lazy is really doing here for you is it's just giving you, and again, as you noted, TJ, you could do this on your own, but it's just really giving you a hook to say, oh, I'm being asked for the very first time to render something. So it's a really good time for me to go get it. Not the only time you could do it, but it's that primary one.
Yeah, and presumably you could even put that in some sort of conditional, right? Like if lazy button, you have some Boolean, right, that triggers, okay, now I'm going to need to go get this, then you could put that in your JSX to wrap it. And then you'd hit lazy button, then you'd hit the lazy callback, right? And then you'd get your code like as an on needed basis, on demand.
And you can even do things like this, like here we're loading this dialog lazily when this runs, but actually technically, if you take this import, if you think about it, it's just something that returns a promise, and I do it out here as a starting point, I can actually understand that this is ultimately going to be something that I could call then on, right? Just like any other promise, and I'm going to get a module, and I could do things. If I don't put it in the React Lazy, it just means when this module loads, now this code's going to start running and doing it, which means if I have 5 or 6 dependencies that I want to load, I don't all have to do them in terms of lazy. I just need to decide when I'm going to do them. So here it's just a function call that happens to run when this module is loaded. Get it?
Yep.
So it's just about really understanding all of React Lazy is, at the end of the day, just understanding that it's just a promise chain. It's a promise chain that's intended to return something that it can render as a component. Okay, and that's going to mean it's the type of thing that takes props and returns something based on those props, so a function. But at the end of the day, import is the type of thing that returns a promise. Suspense is the type of thing that will try to render something, and if it's already been resolved, it'll render it. And if not, it basically kind of does a try catch internally, and it renders the fallback until such a time that this thing actually resolves itself, in which case it re-renders the screen. You can do it all by yourself. It's just things that are kind of being built up together. But the cool part is that if you understand that past the blog post, how they all work, you can use this to do amazing things and lazy loading and of data and UI components and deciding when very precisely your screen re-renders and when you choose to show things and not, et cetera, et cetera.
So this sort of fine-grained control means that even when the app grows very large with lots of dependencies, you don't have to punish your users with this complexity. You can architect sort of what needs to load when and be smart about what not to load or what not to load right now, and then giving a better experience for your users.
You only punish your users if they really deserve it.
Some do.
And you're a one-liner machine here today. This is
this is what I do all the time. It's just I work alone, so nobody gets to hear me, which is really all for their benefit. Just
well, we're coming up on our time here a little bit. I don't know if you want to summarize, because I know you had a couple other things you were going to show. I don't know if you want to like sort of briefly like summarize some of these things, or if you have any like resources or like recommendations for people that want to dive into this, like best places to start sort of thing.
Cool. So start with the React docs. The React docs are actually really good on this as a starting point, and they'll lead you off to other things. As far as the imports, the moment you use that dynamic import syntax, if you're using Webpack, it's smart enough to start making those bundles for you. So there's really nothing else to do but a basic config and start using dynamic syntax for imports. One other thing, there is a library called @loadable/component. Okay, so literally the @ loadable/component. And that thing is interesting. You don't need to use it. It just does some of these same things for you. I'll kick it in the chat for you, TJ. That is the reason I mention that is that if you're also doing server-side rendering of any of your React stuff, some of these things aren't fully supported on the server-side rendering right now. They're only supported on client-side rendering. So pieces like @loadable component help abstract those pieces out. So if you are doing a combination of server-side rendering and client-side rendering, those will save you some heartache of trying to get through this. Other than that, they're really just doing a combination of suspense and lazy behind the scenes, but they're doing it with a little bit of a switch so that if you had something server side, you can, not have the heartache.
Yeah, I didn't even think about that, but that opens like a whole new can of worms to potentially go down with
Yep.
caching and everything. So
Yeah, and there's a ton of them, but it's good stuff, right? Like it's cool that this technology exists, and I'm happy they let it go for us ahead of time and didn't wait to solve all the problems because it's really useful. But it does mean that you might run into something every now and then because technically not all of this is even 100% stable yet.
yeah, I think we got into that a little bit with Christian last week because he showed off some suspense things too, and it's like, well, it's tricky, right? I'm curious. Do you get people that are hesitant to use it because it's quote unquote like experimental? Or are most people okay going like, because it's like experimental, but it also kind of really isn't. So
I wish people were slightly more cautious than they are, because quite literally, I think if it shows up on a blog, like there's things that are totally internal that people I see in the wild all the time right now that are people that are like destructuring some internal property out of a React package because it kind of works. And yes, I've done it too. But yeah, no, I see almost no hesitation with React stuff and people kind of going for it.
okay,
So for better or worse.
yep. Well, cool. Well, I definitely
Yeah.
learned a lot. I didn't know. I knew some of this, but it's been a while since I've used this at scale. So it's good to know that some of this stuff exists and to know what Create React App is magically doing for me a little bit too.
It's cool stuff. But yeah, anyway, play with it. I mean, that's the best thing to do with something like this is find a little use case in a corner of your app and go play with it.
Yeah, and I think what was really cool for me was to see the visual representation and be able to kind of work through that process in the visual way. Like TJ said, it's a lot of boxes, but once you kind of know what it's showing you, it really takes something that's hard to ascertain in source code and easy to understand in a visual sense. So it seems like playing with this type of code has some way to kind of validate what you're doing on the other side.
It's my jam. I spent a lot of time on Webpack Bundle Analyzer.
Nice.
Well, cool. Do you guys, to wrap things up, do you have anything you want to plug to wrap up with here?
I'll throw one thing out there just because they're trying to do a good job. There's a conference coming up November 13th by Geekle on React Native stuff, and I'll be speaking there. So throwing it out less for me and more for them because they're a new conference in this space and they're trying their best to get people to attend. So I'll throw that out there as a plug.
Yeah, they
the
have
name?
some insane level of registrations, right? I can't remember exactly how many it was, but it's a substantial amount.
Yeah, if you search for, I'll throw it in chat. If you search for Geekle, TJ, that's what you're looking for.
Oh,
Yeah.
Geekle. Okay.
Yep. And so here's the thing. The reason I'll actually throw it out there too. I'm pretty sure their whole junior track's just free for anybody who wants to register. And then basically how it works is if the more senior track you pay for. But it's my first time doing anything with them. They seem to be really nice folks. So they do things not just in the React space, but all over. So we'll hopefully it's maybe useful for somebody and they learn something.
Cool. Yeah, November 13th.
All right.
Dan, you got anything?
Yeah, I wouldn't mind mentioning the newsletter again. One of the things I like about the Enterprise React newsletter is all the content comes from our developers. So it's vetted and it's stuff that we liked and we hope you do too. So if you are into that kind of thing, Google it, sign up, and we hope you enjoy it.
Yeah, and I'm going to save them the Googling and put it right in the chat there too.
Man, we've moved up in the world.
I know. And I'll just plug React Wednesdays. So we do these shows every week, same time. We've got some fun guests. We've got another. Michael, you are our first returning champion, but we have our second returning champ, Zain Sajad. I hope I'm pronouncing that right. But
Sajad, yeah.
He did a pretty awesome job the first time, and he's going to be comparing Webpack, rollup, parcel, and I think he's doing like 5 or 6 of these things, like ones I haven't even heard of. So that's going to be a bit of fun. The week after that, we got one of the guys behind _JS who's going to talk about some of the things they did to like break up underscore and like where the project's at nowadays. So
very cool.
That should be cool. And then we've got David K. Piano on Twitter. His actual last name I will probably screw up, but he's doing some pretty awesome stuff. He's the guy behind State Machines, and he's also one of those people that does like the crazy CSS like picture demos that are like make a dog out of CSS only, like sort of nonsense too. So that should be a lot of fun as well. So
a skill I don't have. Yeah. On that side note, for anybody who's listening right now, the bundle stuff, if you're going through the different bundle analyzers, that would be a really cool React Wednesday to show up to, because there's a lot of stuff happening in that space right now. Webpack still owns a lot of it, but there's some really interesting competitors coming on, and each of them has their own little twist on why to do something differently. It'll be an interesting, I think the next year we'll see some really cool stuff happening there.
That's great.
Yep. And Zane's a fun guy. He does a good demo, so should be fun.
Sweet. All right, cool.
All right.
Well,
Thanks
for
again,
having me on,
Michael.
TJ. Yeah.
Thanks, everyone. Until next time, check
Have a
us
great
out.
week.
All
Yep.
right, take care all.
Bye.
Bye.